Hey, welcome back everybody to my object-oriented programming course using Java. What I'm going to touch upon today is late binding, and this has to do with method invocation. As we saw in previous lectures, there are two types of bindings. There's late binding, and then there's early binding. Early binding usually has to do with methods that are static in terms of invocation. Java is going to use late binding for all methods with the exception of static methods. Static. Now you remember what a static method is, right? So a static method, is one where it does not, so I'm going to put an X here, belong to object. So static method does not belong to the object of a class. Or we can say it belongs to an instance of a class. A static method belongs to a class, it's part of a class, but it does not belong to the object of a class. So if you understand that, let's get in a little bit more detail. When I say object, that means you're using the word new, right? New. Then we can say something such as, in this case, new sale. It's a new sale class. So when I create a new sale class, right, a new sale, an object of sale class, that is what we call an instance of the class, meaning that we're allocating in memory. If we have any static methods in this sale class, that means that they are available to us even if we don't have an object instantiated of that class. If you're getting more confused, please look at my video on static methods, and that should clear things up. But I wanted to give you a little bit of a review. Okay, now what does this have to do with binding, late binding? So early binding means that whenever Java compiles your code and it sees a static method, it's going to bind it early, meaning it's going to match up the class with that method, which is a static method. And Java's going to make a decision and say, okay, because it's a static method, we're always going to use this method on invocation. So invocation just means that I'm executing the method. So let's say in sale class, we had a method called bill, right? If bill was a static method, then I can just simply say sale.bill, because we don't need an instance of sale. We can just access bill directly because it's a static method and it's binded early. If bill was not a static method and it was just a method of the instance of a class, then this is what we call late binding. It's going to find out which bill method it's going to use at runtime, right? Most of the time, if you're not running any inheritance, then obviously it's going to use the bill method that is on the sale class. But here's where the tricky part lies in terms of late binding, is with inheritance. Okay, and that's what I'm going to talk about today as to, okay, fine, late binding, what's the difference, right? It's still going to use the bill method in the sale class. Well, there's a difference when the inheritance comes into play. And let's talk about that in a little bit, okay? All right, so now that we got through that, let's talk about, let me give you an example of the classes that I created. One is called a sale class and a discount sale. So let's take a look at that. So here we have the discount sale class and the sale class. The sale class itself is the base class. Nothing fancy. Just has a couple of instance variables here, two constructors, parameterless and with parameter. Then we have another constructor with a parameter as an object. Okay, and that's nothing fancy as well. We have a static method here that belongs to the class. And then we have a couple of instance methods here in the sale class. Okay. Now the one important one that I would like you to pay attention to in this case is going to be the less than method. Okay, the less than method. Inside the less than method, we have a bill method that's being called. And in the sale class itself, we have the bill method over here. Okay, which is one is just returning the price, right? Which the price is just an instance variable. Okay. In the discount sale class, discount sale is now a child of the sale class. Has a couple of constructors. It's calling the super base class constructor. Okay. And then this in itself, the discount sale class, has a bill method that it's going to use. Okay. This does not have the equals or less than because that's already defined in the the base class, the parent class. Now, let's get into the late binding, but before I do that, I just want to draw a visual for you. Okay, so let me go in here, draw one. So we have top here, right? We have this is a sale class, and then the child of the sale class is discount sale. Now the sale class itself has a static method, so we only have one static. Okay, so the static method, again, that means that we can do sale dot announcement, which is a static method. We don't have to have an instance of that class. Okay, let's go back to the code. Okay, now in my main.java, we're going to instantiate a sale object, right? And what we're passing in are two parameters: the name of the item, and then the price, right? So when we're doing this, we are going over here. We have the string and the price, right? And we're just calling the set name set price methods. Okay, so far so good. Then we have the discount sale object that we're instantiating, and that calls the 3-parameter constructor, which is going to be name, price, and then the discount. Right? So if we go to discount sale, we have this constructor that's being instantiated, right, with the name, the price, and the discount. We're going to call the base class constructor, because what the base class constructor is going to do is it's going to initialize the item name and the price. Right? So let's take a look at that real quick. So the name and the price. Right? So remember, we're inheriting the instance variables. We just can't access them directly, but we can get to them by the getter methods. Okay? Then we are going to call the setDiscount method, which belongs to discount sale class. So we got a couple of things here, right? So if new discount is greater than or equal to 0, it is because we passed in a 10, right? Then that is my discount price, right? So far, so good. I think I hope it totally makes sense. Okay. So if we go back to the main, I'm gonna comment this out. I just want to trace through it so that you understand what's going on. Okay. So if I just print this out, right? Compile. So what's happening here is whenever we pass in the system.out.print or we reference the object itself, it's going to automatically call the toString method. Now the toString method is a method that we inherit from object, and we can also override it, which means that for S1 we did override it. So S1 toString is over here, and we're returning name and price and total cost. So what's the name? It's floor mat, right? Because that's what we passed in. Price and total cost is this, right? So we were able to override it from the object class. Remember, everything inherits from object, right? And then the discount will actually inherit the toString from not object, but from sale. But we're overriding that as well. So we overrode it, and we just call get name, right? Same thing, mat price. And now we have a discount, right? So the discount, and then the total cost here is being computed by this bill method. So that's why you get the total cost. So what is this bill method? Inside the discount sale, it's going to do this calculation, which is basically whenever you pass in a number on a third parameter of the constructor, it's going to take a percentage. Okay, so in this case, 10% over $11. Subtract that, and then your total cost is going to be $9.90. Okay, so that's another concept here that we need to understand is whenever you just either print the object out, it's going to reference back to the toString method of the object. If you don't override it, it's just going to print out the object information. In this case, we printed out we created our own toString method. We overrode it, and we're going to return back some string data. Okay, we did it for both discount sale and sale. Okay, so it's a good practice to override the toString method this way that if you do print out the object, maybe you want to print out the instance variables yourself. Okay, now here's where the late binding concept comes in. Let's take a look, and this is a little bit you gotta bear with me here. Okay, so D1 is an object of discount sale class. We've established that. When we call the less than method, right? Again, at invocation, because we're doing this at runtime, right? At runtime, it says, okay, let's go to the less than method. First, it's going to scan here and look for a less than method. It's not here, right? There's no less than method in this class, which means that it's going to go into the sale class and it finds the less than method. Okay, so again, it's binding it at runtime, so it's got to scan at runtime, because just in case there was a less than method in discount, it's got to still scan this object. So that's one example of late binding. Okay, the other example is when we call the less than method, we're passing in a sale object, right, as a parameter, and we are here, right? So if we go back to the main, we're passing in a sale object, which is S1, right? So when we pass in S1, right, so this is S1, right? The one that's calling it is a discount object, which is using the inherited version, okay? And here's where the magic happens in terms of late binding, okay? The bill method, the compiler has to decide which bill method am I going to use. Am I going to use the bill method in sale, which is where we're currently at? So if we go back, there is a bill method here. So let's scroll back up here. Am I going to use this bill method? Or am I going to use, let's go back here. Or am I going to use the discount sale bill method, which is this one, right? That's where the late binding happens. Even though we're calling the inherited method less than, the compiler still has to decide which bill method am I using. So it's got to late bind it at that point in time of invocation. And in this particular case, who called less than who's the invocator of less than? The invocator is D1, right? It's not S1, it's D1, right? Which means that the compiler makes a decision and says, okay, less than, again, we're doing this at runtime, right, when it runs. We're going to go in here. We know that there's no less than method here. We're just going to go into sale. Okay. It comes down here. Okay, this is obviously going to be false. And then it comes to this bill method and it says, hey, there's two bill methods here. So let's go and take a visual here. Okay, so there's a bill method here and there's a bill method here, right? But only sale has the less than, right? Who invoked less than? D1, right? So we said that D1 less than, right? And then we passed in S1, which is sale, right? So when the compiler said, okay, you invoked less than, there's no less than method in discount sale, right? So it says, okay, so I gotta bind it to this one. We gotta call this one. There's no other choice, right? And then inside the less than method, okay, inside the less than method, there's a bill call, right? So if we look back at the code, okay, there's this bill call, right? And the compiler has to say, okay, which bill am I going to use? Am I going to use this one or am I going to use this one? That's where light binding comes in at runtime, right? And because the discount sale, D1 is an instance of discount sale, it decides that it's going to use this one, okay? Because there is a bill method in D1. Now, if there was no bill method in discount sale, then it'll happily use the one in sale, right? But in this particular case, the late binding occurs because the compiler is going to associate the bill method to the caller of that method, okay? And when it sees 2, it says, okay, what object are you in? Well, I'm not a sale object. I'm a discount sale object. Okay, so let's use this one. So Java takes care of that for you. You don't have to make the decision yourself. Okay, and again, we're talking about inheritance. Okay, so this is a totally different ballgame if this doesn't make sense if there was no inheritance. And this is what late binding is about. Okay, it says, oh, okay, I'm going to decide because you are a discount sale method, then I am going to bind to the bill method in discount sale. Now you're probably wondering, okay, what about the other call here, right? This bill method. Well, this bill method is being called explicitly by sale. So because it's a sale object, the late binding says, hey, I know that you're a sale object and I know you're calling bill, which means that it can't possibly make any other decision because other sale is a reference type of what? It's a reference type of sale, right? That's its reference type, which means that it says, oh, okay, so since that's your reference type and you're calling the bill method, then we're going to call the bill method inside the sale class, so which is over here. Okay, so if we run this completely, you're going to see that the discount item is cheaper, which makes sense, right? Because we're comparing 10 to 11, but the discounted item is 10% off, which means that it is cheaper, and that makes sense. I hope I clarified a little bit about late binding, and again, this only makes sense with inheritance. And we also talked about the toString method, which we overrode. Okay. On the next video, I'm going to talk about the final modifier, and it has to do with late binding as well. And I hope to see you there.